Hello. Today we will continue with chapter 3, which is projectile motion, that is motion in 2 dimensions. And over here, what I want you to remember that the displacement vector is now delta x, has 2 components, which are delta x, delta y. The velocity vector, it has 2 components, vx, vy. And the acceleration vector has 2 components, which is ax, ay, where ax is 0, which means the x component of the velocity vector does not change, and the ay is minus 10, which means the y component only of the velocity vector is changing. And how do the new equations look like? They look like this. Okay, delta x is v initial x delta t. Normally we have a plus half ax delta t square, but ax is 0, so there is nothing. Delta y is v0 y delta t plus half ay delta t square, and ay is minus 10. So we get this. Vx is equal to v initial x, which means the x component of v does not change along the way. And Vy is changing in such a way that Vy is V initial y minus 10 delta t, and Vfy square is V initial y square minus 20 delta y. This usually looks like V square of y equal V initial square y minus plus 2 ay delta y, but ay is 10, so we get this equation. So let's do 2 more exercises so as we try to remember these equations. Okay, before that, I just want to make very quick revision for a vector, how to get its component. The most important vector we will be dealing with in this chapter, apart from the acceleration, which is always downward, and the x component is 0 and the y component is minus 10, it is the v initial. If v initial is horizontal, then the x component is all of the initial. The x component is all of the initial because it's all on the x-axis, okay? However, the y component is 0 because it doesn't go up or down. It doesn't go up or down. Look at the red vector. It's just going to the right. It is not extending up or extending down. So here we say the initial is horizontal, the initial x will be whole of the initial, v0y will be it will be 0. Example, if they say v0 equal 5 meters per second and is horizontal, this means v initial x is 5 meters per second, v initial y is 0. Okay. Another example, if it's making an angle, so if v0 makes an angle theta with the x-axis, now v initial x equal v initial cosine theta, v initial y equal v initial sine theta. Okay, v initial x and v initial y are the x and y components of vector v initial. Example, if they tell me a ball is thrown with a speed v initial equal 5 meters per second with an angle theta equal 25, implies v initial x equal v initial cosine theta. This will be 4.53. And v initial y is v initial sine theta, and that will be 2.11 meters per second. These are the x and y components of the initial. But if you remember our discussion about vectors, this v 5 meters per second, it's the magnitude of the vector. And this theta equal 25 is the direction of the vector. And these are the x and y components of the vector. Okay. Now, I just want to add one more definition before I move forward, which is the range. The range of a projectile is how far the object travels along the x-axis before it hits the ground. So imagine here I'm throwing a ball from top of a building. It will go up, 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 and then it will reach the ground and hits here. So the range is from where it was hit till where it reached, okay, on the x-axis. So it is delta x. It is delta x, where delta x is v initial x delta t. Okay. this is delta x. So this is the range. It just has this name, but it's simply delta x from where you hit the ball. So where is the x of this ball until it reaches the ground? Okay. Sometimes you may hit something, not hit something, like imagine here there's a football athlete. He will hit the ball and it will go back to the ground. So this goes from the ground to the ground. The range is also this delta x, okay, from the ground to the ground. In this case, by the way, delta y is how much? From the ground to the ground, delta y is 0, okay? However, here, delta y is not 0. It is this amount, and it is negative because it is downward, okay? So this you have to remember. However, here, delta y is 0. Okay, now I think we are ready to do 2 small exercises. A rifle, this is يعني بارودي, okay, is aimed horizontally at a target 50 meters away. So what is this 50 meters? This is delta x, okay? This is delta x equal 50 meters, okay? So this is here the range actually, because it's from where it was hit till where it reached. This is the range. The bullet hits the target 2 centimeters below the aim point. So what is this here? What is this? This is delta y equal minus 2 centimeters. Why minus 2? Because it's going downward, however, y-axis is upward. What was the bullet's flight time? What was the bullet's flight time? What does it mean, flight time? Flight time is the time during which the bullet it took to reach the wall, okay? So this is flight time. So here, in order to solve it, I have 2 pieces of information only. What are the 2 pieces of information I have? I have that delta x equal 50 meters, and I have delta y equal minus 2 centimeters, which is 0.02 meters. Okay, I have to change it to meters. These are the 2 pieces of information I have. Let's see which one of these 2 information I can use to calculate the time. Let's look at delta x. Delta x, if I start by the first equation, it's v initial x delta t. Do I have v initial x? Actually, I do have. In these exercises, if you look at, you directly locate what is your v initial x and v initial y. So this is v initial, right? It is horizontally. V initial is horizontal. Let's put it here. V initial is horizontal. Implies v initial x is equal to v initial, and v initial y is equal to 0. Okay? Because it is horizontal. Now, so I also have these 2 pieces of information. So let's start with delta x. V initial x, it is v initial, but I don't have it. So I cannot use the first equation. Let's see the second equation. Delta y, it is minus 0.02, I have it. V initial y is 0, I have it. And this is 5 delta t squared. So this is the equation I can use. Here there is no delta t, here there is delta t, but I don't have the vy. And the same thing here. So the only equation I can use is the second equation. So let's use it. Delta y equal minus 5 delta t squared. Okay. So delta y is minus 0.02 equal minus 5 delta t square. Here we divide 0.02 by 5. So minus 0.02 divided by minus 0.05 is equal to delta t square. Okay. So we get delta t square is equal to, you just use a calculator, okay? It's equal to 0.004. That delta t equal sorry, here this is not 0, this is 5. So this is delta t square equal 0.04, and we get delta t equal 0.06. Okay. So this is part A. Part B, what was the bullet's speed as it left the barrel? Okay. So now we use the second piece of information, which is delta x. So delta x, because now we have delta t, we can use the first equation. Delta x is equal to v initial x, which is v initial x, which is v initial, is over here. Okay. So it's v initial delta t times v initial times delta t. Delta x is 15. This is equal to v initial times delta t, which is 0.063, implies v initial equal 50 divided by 0.063 equal 790, around 790 meter per second. So this what we got is v initial, and this is the speed. Okay. So let's do another exercise. Here it's only one component. So v initial x is the whole of v initial. So this is the magnitude actually of v initial. And we know that the direction is horizontal. So here if we have to say magnitude of v initial is equal to 790 meters per second. There are no two components. It's one component. So it is the whole of it. And direction is horizontal. The full solution is in the next slide. Okay, so here is v initial x, v initial y, delta y. We substituted v initial y equal to 0, and that's how we did delta t. And then from delta t and the range, or delta x, we calculated v initial. Let's do the following exercise. Number 6, a sprinkler mounted on ground sends out a jet of water at a 30 degrees angle to the horizontal. The water leaves the nozzle at a speed of 12 meters per second. So here they gave me the initial and they gave me the angle. Okay. Now the first part, let's start here. Determine the horizontal and vertical component of the initial velocity. Here you have to remember v initial x is v initial cosine theta, and this is equal to 12 cosine of 30, and the answer is 12.4, 10.4, sorry, 10.4 meter per second. V initial y is v initial sine of theta, which is 12 sine of 30, and this is equal 6 meter per second. Okay. Determine the time of flight from the beginning till the end. Determine, that is, we want to calculate delta t. We have to calculate delta t equal how much? Okay, let's see what other information we have. The ball goes from here. This is not ball, this is water, sorry. This is from the ground. It goes up, 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 and then it goes back to the ground, actually. Okay, so it's from the ground to the ground. How much is delta y in this case? From the ground to the ground. It was at origin 0 and it went back to also y equal to 0. So how much is delta y? Let's do it here. Delta y equal to 0 because the water came back to the ground. Water went from ground to ground. So delta y is 0 ارتفاع. Okay, so let's use the equation delta y because we know how much is it. It's v initial y delta time. This is the second equation minus 5 delta t squared. Okay. Delta t squared. So delta y is 0. This is equal v initial y. We have just calculated it, 6 times our unknown delta t minus 5 delta t, all of it squared. Okay, so this is a quadratic equation which has delta t squared, delta t, and some numbers. Actually, this is an easy quadratic equation. You can either use the calculator on a quadratic equation to solve it, but it's also easy if we take delta t as common. Delta t as common from the first part would be 6 minus 5 delta t equal to 0. I just flip them around. Okay, so 5 delta t, I took it to the other side, minus 5 delta t squared, I took it to the other side, and 0 to the other side, and then multiply all by negative. There is no problem. So delta t, this means delta t is 0 or 6 minus 5 delta t equal to 0. So it's either the first part is 0 or the second part of 0. The first one is rejected because that's the time when it left. Implies the second one is correct. So 6 equal 5 delta t implies delta t equal 6 over 5, which is 1.2 seconds. 1.2 seconds. So this is part B. Last part C, let's put it here. How far does the water travel before it hits the ground? So from here to here, how far does it go? From here to here. So what is he asking for? He's asking about delta x, or what we have just called it, the range. Okay, so this is the range. So the range, or delta x equal the first equation, the initial x delta t. Now I have the initial x, which is 10.4 here, 10.4 times delta t 1.2. How much will this give me? Times 1.2. And this is 12 equal 12.2 around 12.5 meters. Okay, so this is the second problem, and it's the last one for today. You can find the full, you can also find the solution here. This is the solution. Okay, so here 0 equals 6 delta t minus 5 delta t squared. You can solve it using a calculator. You will get these two answers, or you take delta t, as I said, as a common factor, and you will get delta t equal to 0 or 6 minus 5 delta t equal to 0, and both will lead to the same answer. So this is our lecture for today. Tomorrow we will be solving also more exercises, and in the live session I will be reviewing vectors, trigonometry. We will do these things together. Okay, so that's it for today. Have a good day.